This is Mr. Anderson for Keller Community College. We'll be doing Chapter 7, Section 6, Solving Radical Equations. We'll be solving for x in the first part of our two-part video for this section. Now, the first 8 problems of our work here are going to employ a general strategy. The first thing we're going to do is to try to isolate your radical. So, isolate the radical that you have in the problem by getting it all by itself on one side of the equal sign, either the left or the right. And we will use inverse operations like addition, subtraction, multiplication, division to try to do so. Then we're going to use our rules to solve for x. And there are many of these rules that you've employed earlier in our work together. And then finally, since we will be squaring, cubing, and taking the fourth power of these radicals to get the x all by itself, we need to check your answer. And that's important because you can get an answer and have that answer not actually work for the problem itself. And in the first 8 problems, we're going to see that we are going to have one of these problems not quite work out for us. So let's go and get into the problem. In problem 1, we have to isolate the square root. Now the square root has a -1 bothering it, so I'm going to add 1 to both sides. So what I have here is the square root of 2x is equal to 3. Now to get rid of the square root of 2x, I have to square both sides. And since this right-hand side is a monomial, 3 squared is easy to square, which is 9. And due to simplification, this would be the square root squared, and these are opposites, so that would give me what's in the inside the radical 2x. Divide both sides by 2, I get the answer of x is equal to 9/2, which is 4.5. This is the answer for x. When we solve for x, we can have decimal answers. And what's important about that, we should check our work by plugging our 4.5 back into our problem. So what we have here is 2 times 4.5, which is 9, minus 1 equals 2. Or 3 minus 1 equals 2, which is a valid answer. This checks out, so 4.5 is correct. Noticing in problem 2, we're going to do the same thing. Move the 6 over to the other side by subtracting it. Now I have the square root of x plus 4 is equal to 7 minus 6, which is 1. Square both sides because I want to get rid of that square root, so this leaves me with x plus 4 is equal to 1 squared, which is 1. Subtract the 4 from both sides, and I get x is equal to -3. Now, what I'm going to do is check to see if this works by plugging it back into my original equation. I promise you, you'll want to do this for every question on the test. So this is going to be -3 plus 4 plus 6 equals 7. -3 plus 4 is 1. The square root of 1 plus 6, the square root of 1 is 1. 1 plus 6 is 7. 7's equal to 7, so therefore it checks out. This is the correct answer to the problem. Alright, let's do these next 4. So, what's nice about problem 3 is problem 3 is already isolated. That means that the problem already has the radical all by itself on one side of the problem. So the opposite of the fourth root is taking things to the fourth power. That means I'll have x plus 5 because the fourth root into the fourth power is just going to be x plus 5. 2 to the fourth power is 2, 4, 8, 16. Subtract 5 from both sides. X is equal to 11. Now it is important that I check my work by plugging my 11 back into my equation. So I'm going to take the fourth root of 11 plus 5, and the fourth root of 11 plus 5 is the fourth root of 16. The fourth root of 16 is 2, which was equal to 2 the whole time. So my answer checks out. X is equal to 11 is the correct answer. Now, number 4 is written a little strangely, but it's really 3 times the square root of x plus 12 equals 9. Common mistake is people think that the 3 is included in this square root or this 1/2. That's not the case. The only way for the 3 to have been part of the square root is if the 3 was in parentheses with the x. So now this changes the problem a little bit. We're going to subtract the 12 from both sides. So what we have is 3 square root of x is equal to negative 3. Divide both sides by 3 to get the square root of x all by itself, and we have negative 1. If we square both sides, and be careful when you type this in on a calculator, the x is going to be equal to the square of negative 1, which is negative 1 times negative 1, which is positive 1. If you don't use the parentheses on your graphing calculators, you will get the wrong answer. So now it's time to check the 1. I'm going to plug this back into my equation. 3 times the square root of 1 plus 12 equals 9. So this makes 3 plus 12 equals 9, or 15 equals 9. This is not true, so this is not the answer. This has no solution. This is a no solution problem. Problem number 5. Start out with the fourth root of x minus 2 equals 1. Move the 2 to the other side. The fourth root of x is equal to 3. We're going to take the fourth power of both of these. So x is equal to 3 to the fourth power, 81. So let's go check my answer. I'm going to take my 81 and plug it into the fourth root here. So 81 minus 2 equals 1. The fourth root of 81 is 3. 3 minus 2 equals 1. It checks out. That is your answer. Okay, for this problem, I'm going to add 5 to both sides. So now I have the fourth root of 2x plus 3 is equal to positive 3. If I take everything to the fourth power, like so, I get 2x plus 3, because the fourth power of the fourth root is just whatever's inside the radical, and 3 to the fourth power is going to be 81. 3, 9, 27, 81. Subtract 3 from both sides. 2x is equal to 3 from 81 is 78. Dividing both sides by 2, x is equal to 39. Now I'm going to check my answer by plugging that back into my equation. So the fourth root of 2 times 39 plus 3, I wrote a 5 instead, minus 5 is equal to negative 2. Alright, let's go process this inside of the fourth root. 2 times 39 is 78 plus 5, and 78 plus 5 is... Oh wait, 78 plus 3. I did it again. Shoot, that's a 3 in there. Look back at the original problem. 78 plus 3 is 81. The fourth root of 81 is 3 minus 5 equals negative 2. It checks out. All of this checks out. So we have the answer to number 6 is 39. Alright, we're going to do 2 more problems for this video, and then we'll take a break and do the next video for the last 4 problems. Because up until now, up until problem 7 and 8, we all can use the same technique. So here comes problem number 7. We're going to move the 5 to the other side, subtract 5, subtract 5. So I've got the cubic root of 6x plus 9 is equal to negative 3. Now what I will do here is I will multiply everything by the, or actually take the cube of all of these here, and this is going to give me 6x plus 9, and this is going to give me negative 27. Something a lot of people leave out is the negative. Negative 3 times negative 3 times negative 3 is negative 27. Move the 9 from the left to the right. 27 minus 9 is negative 36. And then we divide both sides by 6, which gives us negative 6. So, as like we did in the last 6 problems, we plug the negative 6 back into the equation. So, taking this from the top here, I'm going to have the cubic root of negative 36, because negative 6 times, this is negative 36 there, plus 9, plus 5 equals 2. Negative 36 plus 9, this is the cubic root of negative 25 here. Now this is important here because I got negative the cubic root of negative 27. I wrote down 25 by mistake, plus 5 equals 2. The cubic root of negative 27, I'm sorry that doesn't look like a negative 27 there, is going to be negative 3 plus 5 equals 2. Negative 3 plus 5 is 2. That's your answer. And for our final problem here, we're going to take 2, and this is the 1 minus x in the cubic root, is equal to the cubic root of 4. Now here's what's funny, because I'm going to first of all divide both sides. Now you would think that you would divide both sides by 2, but in fact I'm going to divide both sides by the cubic root of 1 minus x. See, I want to get my radicals all over to one side of the equation. So now what I have left here is 2, and I have here, using my quotient rule, 4 divided by 1 minus x. Now I can take everything to the third power, which will make my right-hand side just 4 over 1 minus x, and my left-hand side is going to be 2, 2, 2, so 8. Now I can use the power of cross multiplication, or rationalizing the denominator, and multiply both sides by 1 minus x, which gives me, on the left-hand side, 8 minus 8x equals 4. Moving my 8 to the other side, this gives me my negative 8x from this left portion here. Just to show you where I'm getting this from. The negative 8 is on the left-hand side. I move that 8 over here, and this is going to be 4 minus 8, so negative 4. Dividing both sides by negative 8, x is equal to negative 4/8, or positive 1/2. That positive 1/2, I'm wondering if it's going to work out, so let's go try it into this part of the equation. So now I have 2 minus, 2 times the quantity of 1 minus 1/2 raised to the 1/3 power. So what I have here is 2 times the quantity of 0.5 raised to the 1/3 power equals 4 raised to the 1/3 power. Now at this moment it might benefit you to try to just turn on your calculator and see what they will compute to be. Now sadly, if I turn on my calculator, all of this will be erased on the screen. So please make sure that you have this written down before I go to my next step. Okay, so what I'm going to do is go to my calculator, which I have on my computer here. Alright, and I'm going to bring the worksheet back up again. There we go. Let me clear this out for you. Now again, my x is equal to 1/2, so I'm testing if 2 times 0.5 raised to the 1/3 power is the same thing as 4 raised to the 1/3 power. Whoops, let me delete that. And it is. So that saves us a lot of manipulation. And besides, on the test, your real goal is to see if you've done the problem equivalently and make sure it equals out. Thanks for watching.